Hello!
Hi, welcome to Dad and Kids Coding, where we're doing Advent of Code 2020, and today we're on day 10. So it's kind of a amusing but confusing description of the problem here. Basically, we need to figure out which adapters we put together in which order, and it turns out that they have to go in ascending order, so basically we just need to take this list of values and sort them. And then what we want to know is the number of times that there is a 1 jolt difference between these and the number of times there's a 3 jolt difference. So for this example, there's 7 differences of 1 jolt and 5 differences of 3 jolts, and so you multiply them together, so 35 is the answer. We give another example here, and this one is 22 times 10, or 220. Okay, so the only tricky part is that the starting point is 0, because you're going to plug it into a 0, so that means there has to be a 1, 2, or a 3 in the input. And the final joltage output is 3 higher than the highest one. So that means that there's always going to be a 3 jolt count in addition. Okay, so let's go to our... So I've already put the data, the tests in here. So here's that first one, so it equals 35. The second one equals 220, and the third one, using the data for day 10, is unknown. So let's run this. So I also wrote this helper function as lines then numbers, which takes this string and turns it into an array of numbers, just to make it a little bit faster. Okay, so our instance of array did not understand day 10, then we should create it. And put this in array. Again, do the standard thing of browsing it, and then putting it in the right category. Oops. Day 10, extension, Advent Code 2020, okay, close. Okay, so we're back here. So we have our array here, and we need to go through this. Well, we need to sort it first. So self-sorted. And then we want to loop through this and count the number of ones and number of steps up by 1. So we're going to loop through this. So we'll do, and I don't know, joltage, let's just say. And what we need here is we need to check to see if the joltage minus the previous joltage is equal to 1. If true, one count will advance. So I'm just going to call it 1 plus 1. Okay, so we'll copy that because we, oops, copy. What did I just do? Something weird, anyway.
I don't think you're the problem, I think it's the problem.
I think the computer is the problem.
Not in general, just now.
Okay, I don't know what I did.
I think it's just having a little fussy time.
Just make that go away. And yeah, that's what I thought I'd done. I accidentally pasted in a big thing, and it was busy trying to
Oh, so
formatted.
you were the problem.
Yes, that was the problem. So undoing it is also going to take time, probably. Almost be faster to just start it over again, but there we go. Okay, so okay, select all of that and delete it. Okay,
There we go.
so so let's go back here and do that. So this is if it's 3, then 3's is 3's plus 1, and we want to define previous. I probably should spell it out. Previous 1's and 3's, and 1's. So we start off with, well, let's make 1's and 3's. And previous. All be 0. Because the starting voltage is 0, so let's just okay, and then we need to say that the previous voltage is voltage. So once we're done here, we just have to add 1 to the 3's because of the final jump to our device, and so we'll just return 1's times 3's plus 1. And hopefully that's all we have to do. So we sorted the array. So let's look at see what self-sorted looks like. So it's just these numbers. So there we see there's a 1 jump from the 0 to 1, and then a 3 and a 1 and a 1 and a 1 and a 3 and a 1 and a 1 and a 3 and a 1 and a 3. And
It's
another
all
3.
lyrics.
Yeah, thanks. So let's proceed and see where we get to. And it worked, and except here's our result for the unknown case. So we'll proceed, and it works. Okay, so let's go over here and see if that's the correct number here. And it is. Woo! Excellent. So continue to part 2. Okay, so not surprisingly, part 2 is a lot more complicated. Have to figure out how many different ways they can be arranged. Every arrangement needs to connect the charging outlet to your device. Previous rules about when adapters can successfully connect still apply. First example supports the following arrangements. So not just the in order one, but we could skip some. So they're always in order, but we can skip some. Okay, given the adapters, the total number of arrangements that connect the charging outlets to your device is 8. Second input has many possibilities. Okay, so this is much more complicated. So let's take this, and so now this is day 10b, and day 10b, and it equals 8, and this is day 10b, and it's going to equal what? 19,208. Okay, and this is the unknown again. Okay, now, so we'll create this method in array. Again, we'll browse over, class size. Okay, so, much more complicated. So we still want to go with the sorted values, except we want to go through and find out. Let's just see what self-sorted looks like. Well, actually, in the example problem, they have it sorted, so let's just go back to the simple one. Okay, so as we go through, we see I don't know whether we have to loop through and find all the possible arrangements. So we could write a function that if we gave it the rest of the array, it would tell us how many options there were from this point on. And we only have to step, we only have to look at a couple beyond this, because when we're at 0, we have to look at this one and this one. As soon as we find one that's more than 3 away, we're done. But here, once we've seen the 1 and the 4, we could follow it by 5, 6, or possibly 7. So we have to look at these 3 possibilities here. So here's when we do 5 and then 6 and 7. Here's when we do 5, 6, 7. It's different at the end. Here's where we do 5 and then from there we skip to 7. Another one with 5 and skip to 7. Here we go from 4, skip to 6, and then 7. And here we have a 4 and skip to 7. So those are we only have to look ahead at the next 3. So let's self-sorted. And so we're going to need a helper function here. So say self count actually let's put this in an advent of code new. No reason to put it in array, so because we're not actually using self. Oh no, we could do it this way. Yeah, okay, never mind. Do it self-sorted. Count from 0 to, and the endpoint we want to be okay, I'm gonna to self max plus 3. So the maximum value in this array plus 3 is the final result, which means that the final one is not going to, we actually don't have to worry about the last one because it's always 3, so the one before it couldn't possibly be up to it, so we don't have to do that. So we'll just do self max. Oh no, actually we don't even have to do that. We just have to say count from where we're counting from. And then we'll add 1 to this. I think that's right. Oh no, we don't even have to add 1 because that last step is always the same, I think. Okay, so let's try this. Okay, so let's proceed. And there is no count from. So create that, put it in array, and again, so we'll worry about that later. Okay, so what we want is to say we want to return, let's see. So first possibility is that we're an empty array. So if we're an empty array, then the count is 0. So if self size is 0, so this is what's called a recursive solution, which means we're going to actually use the same function that we're busy writing. So we have to put in a base case, and this is the base case. We get a size of 0, then there is nothing further to do. So we're just going to return 0 in that case because there can't be any solutions in if we have an empty array. Maybe 1 is the correct answer, but let's see. So let's see what's next. So if so we know that the problem works, the solution works, so we know that the next value has to work. Does it? No, it doesn't, because we could be trying from a different starting point. Okay, so if let's call this base. If the base plus self first, base plus um, 3 is greater than or equal to our first value, then this is a valid 1. So that's if true. Then we want to return first. Count from, I think I got this right. Count from self first. So, if base plus 3 is greater than self, then there actually is a sequence that starts with the first value. So that's the plus 1. And we want to look at all the rest of the list, skipping that one, but starting from whatever that first one is. Okay, I think that's right. And then now we have to make sure that that self is long enough. So if self size is greater than 1, then if that's true, then we can do basically the same thing as before, except from a different starting point. So if base plus 3 is greater than self second, if that's true, then we'll return 1 plus all but first 2. So we'll skip those first 2 and count from self second. Okay, and this is if self size is greater than 2, then we will check to see if self third is in range, and if it is, then we'll do all but first 3, count from self third. Oh, no, we don't want to return in those cases. We want to add up those cases. So, count 0, and so this will be count plus 1. Okay. I don't know. We'll see. So count is a temporary variable. Oh, and then when we're done, of course, we want to return count. Okay. We'll see. Let's just proceed and see what happens. And we didn't get the right answer. We got 49 instead of 8. That's a big difference. Okay, so my theory doesn't seem to be quite right. So let's restart and step over that and then step into this. Okay, so we clearly want self-sorted, but then let's see what count from looks like. Okay, so self is the array 1, 4, whatever. Oh, maybe I got this part wrong. Maybe because we're definitely getting way too big a number. So let's take these out. And return 1 here instead. Because we have to have a 1 somewhere in this, or we'll never. So let's just proceed and see if that works. Ah, it did. Okay. So, I'm surprised that the bigger data set has a smaller count, but let's assume it's right.
That might have been our old, and whatever, we'll see, it'll tell us.
And so we'll scroll down and put that value in here, and it's not the right answer, it's too low.
Right.
Okay, so, Interesting. So, let's restart. And let's just actually go. So this is not correct. So go back to unknown. And then we'll step over the first ones that produce the right answer. And then we'll step over that, and then step into this and see what we got here. Oh, I didn't change it. It still said day 10A. There you go. Let's try day 10B.
That's why I was getting it. I saw it and I thought, isn't the answer from part 1?
Right, okay. So let's proceed now. It's taking longer, which I kind of expected. Test took too much time. Huh. Yes, it's a big array. So, we probably can find a more efficient way to do this. Let's go and see if we can. So right now I'm making copies of the file, which is a pretty expensive way to do this. So let's see if we can come up with a better way of doing this. Sorry, day 10B. So we're using the count from, yes. So let's move count from to admin of code. Okay, and back to this. So count from. So rather than doing an all but first, we should probably make count from have a starting point as well. So let's add an extra parameter to this. Refactor add argument. And so I'm going to call count from start at. And I don't know, let's say 1. And so so count from day 10B. Okay, let's just apply that. Okay, so day 10B now says count from 0 starting at 1. Okay, so let's then go to count from start at. Okay, so starting at start. And so what we want to do is, rather than do the all but first, we'll tell self to count from here, starting at, and we don't want first anymore, we want self at position start. Okay, so if that's true, then we want to do self count from, not self first anymore, but self at start. And we don't want to start at 1, we want to start at start plus 1. And we don't want, so this isn't, it's not self start size, it's not self size anymore. It's if self start is less than, self size is less than start, then there's nothing to do. So so let's just have to make sure we get all these changes right. Self count from self at start. Okay, so now it's not a self size. If it's less than, no, it's greater than start plus 1. If that's true, then we'll do self at start plus 1. If that's true, we'll do this, and we don't want all but first, we just want to do the self count from. And we don't want self second here, we want self at start plus 1. Start at start plus 2. And finally the third one, this is if size is greater than start plus 2. If it's true, then at start plus 2. If that's true, then we want self count from self at start plus 2. Start at start plus 3. I think I've got it right. We'll see. Use the size, not anymore, it doesn't. Okay, so set our count to 0. If self size is less than start, then we're past the end of it, so we should return 1. Otherwise, if base plus 3 includes the value of self at start, then we should do counted. So we'll do a count from self at start, because that's what the count is we're going to use, or the starting point is, and then we want to start at the one after. And otherwise, start at start plus 1, start plus 1, start plus 2, size greater than start plus 2, start plus 2, start plus 3. Okay, so we'll see. Let's go and run our test. And no. Okay, why is that? Because I didn't put parentheses around things properly, so it's trying to do. Okay. Save. Okay, so we didn't get the correct number. Number we got is too small. The first one worked. Huh. That's unfortunate because the second one's much bigger. So it's harder to track down why it's not working. Well, let's do it. Step over this first one. Okay, so we don't have to do the sorted. Okay, so now the array's not that big. Let's just see, look at the first couple values and see. So self size less than start, clearly it isn't, so that's going to be fine. Then we're going to look at base plus 3, which is going to be 3. Is that bigger than self at start? Okay, yes it is. So we're going to count from self at start. Okay, so let's go into the recursive count from. Okay, so now we're inside count from, call from count from, and base is 1 because we're assuming that, and count is, start is 2. Okay, so that's fine. So step over, step over, step over. Yes. Okay. Do this. So now we've got 2. We're trying to see whether 3 works. So let's step over. Actually, let's just go back over to the example that they give us because they tell us a bunch of information. So we have the 1, 2, 3, 4, 7, 8, 9. Yeah, they didn't do anything exhaustive. If they told us all the ones that started with 1, 2, if they'd given us all those, then that would make it a little bit easier to catch this. But okay. So as we step through, hopefully we'll figure out the problem. So I'm going to. So we're currently at looking at the starting point of 3. So if base is 2 plus 3 is 5 is greater than or equal to 3, that is true. So I'm just going to step over this case. Assume that does the right thing. So count, got a lot of cases from those. Then let's try size greater than start plus 1. Yeah, so all these are going to be, because we're early in the array. Then is the base, which is 2 plus 3 is 5, bigger than start at self at start plus 1. Start is 3, so that start at 4, which is 4. So let's step over this case. And yes, it is, so we'll do those. Okay, now is size greater than start plus 2? Yes, it is. So is base plus 3, which is 5, greater than or equal to self at start plus 2? No, so we shouldn't. We should go from 2 to 7. Right. So it looked like it did the right thing. We were at here, and we did the one that started at 3 and the one that started at 4 because they were plus 1, plus 2, but 7 is plus too many, so we didn't do that one. Okay. Huh. Let's restart and step over. I'm missing a case. Trying to figure out a way to debug this. It's a pretty big array to go stepping through, single stepping. So let's see if we, why don't we put a halt here. So we'll run until we get to the, end, and then we'll see what we're, so let's just say proceed. Okay, so we got here. Now, base is 49, and clearly we're at the end, so that's right. And start is 32, which is the position we're at. So, and the size, self size, it must be 31. Indeed it does. Okay, so we're past the end of the array. So we're going to return 1. So let's look at the preceding ones. So here we were doing 48 to 49, yeah. And then we were, before that we were doing 47, 48, yeah. Before that we were doing 46, 47, 45, 46, and 42, 45. That's right. 39, 42, which is right. 38, 39. 35, 38. 34, 35.
I saw 21 there. That's interesting.
Yeah, because that's the position in here. So it's the 21st element.
Fool, sorry.
It's okay. We're not a fool. Okay, so all of these are what I expect them to be. Okay, so let's just proceed again, and we'll see the next time we come to the halt. Okay, so the next time we came to the halt, was from this one. So here was 48, and 48 got skipped ahead from 46, which is right. Why didn't we get to 49 from 47 first? Okay, so here we are at basis 49. And the one before that should be 47 trying to reach ahead to 49. Ah. I think I'm testing to see if the array is bigger than it is. So let's change these. Save this and go back and rerun the test. Okay, so we halt here. Oh yeah, no. Yeah, it's only going to count to 8, so we'll just. Okay, so still on the short array. Okay, so we're on to the bigger array now. So this is the first time, and so here we have 49, 48, and these are all going to be the first step. Okay, so let's proceed. Here, proceed. And now we should see, so we're at 49, and this one should be from 47. Yes, it is. Okay, so I think that was the problem. Okay, so let's take the halt out now. Save. And proceed.
Oh, taking its time.
Ah, test took too long. So what happened here is that the way we're going at this is we have to go back and forth too many times. So we try 1, and then we try all the possibilities. And then, so if we did 1 and 2, then we try all the possibilities. Then we go back and try 1 and 3 and all the possibilities. But the way it works is the last possibilities are kind of stacked up. So once they've been decided, they can't be redone. Their value isn't going to change. So the last one is always going to be work. And then the one before that, there's 2 ways. It could end there, perhaps, or it can do the last one. And then the one before that might end there, or do the next one, or do the last one, and so on. But once those have been done, they don't change. So the problem is that we're doing those tests many times. So there's a technique for this called dynamic programming. And basically what dynamic programming is we're going to add a memo that remembers values we've already seen. This doesn't always work, but for certain kinds of problems like this one, when the deeper cases are repetitive, they don't change, then you can have this, we can find a fix for this. So what I'm going to do is I'm going to add another parameter to this method, and this parameter add argument, and I'm going to call this with memo, and nil is fine for that. And so what it's going to do is it's going to, everywhere I call this, I'm going to have an extra parameter. So one of the places that I call this is here within this. So I'm going to call this memo, and I have the memo here and here and here. And so what I'm going to add to this now is, if the size is less than the start, this doesn't change because we've gone off the end. But what we'll add here is, if the memo at position start is not nil, then I'm going to have then I've got a value, and I'll just return that value. So what that means is that once I've gotten to a certain point and I've calculated that one, I won't bother to recalculate it. So, and then the final part is down here. Then we'll add to the memo at start put count. Okay, so basically what we're doing is we're saying we're going to keep this memo around that's going to remember values that we've already calculated. And when we see one of those, I'm just going to change this formatting a little bit just because it's taking up too much screen space. So now we can see the whole method. So we will pass in this memo, which is going to remember things that we've calculated. And so we'll check for if we're beyond size, because the memo is going to be the same size as the original array. So this has to be checked first anyway. But then after that, we'll just check to see if we've already calculated a value from this position. And if we have, then we just return that value. And if we haven't, then we go through and we calculate it, updating the memo for other locations as we go. And then when we're done, we put this count into that position in the memo, and then we return the count. So we don't have to recalculate these values over and over and over again. So I'll save that. And now we need to find the senders of this, because this is called from within itself in its recursive call, but it's also called from day 10b. And so in day 10b, we have to give some useful memo value. And what we'll do for this is we'll just say that we want an array new self size. So we're creating an array the same size as our object, but that has that's all nil. Because we create an empty array of the size, it initializes it all with nil values. So then we'll pass that in, and then as we calculate values, we'll fill them in until everything is done. So we'll save that, and now we'll go back to our test, and we'll run our test. And our test runs fairly quickly, and we get this big number, which hopefully is the right one. Okay, so we'll save this and proceed. Now runs, and as you see, it runs very quickly because the values actually only have to be calculated once. So let's go over here and see whether this is the correct answer. And we'll say this, and it's the right answer. So we're done.
Well, that was quick.
Yeah, so once we figured that out, so this is a very general technique. It's useful in all sorts of problems where you have this, where we're recalculating values over and over and over again. So we'll just go and save this, and then we're good. So let's commit this, And so we have this method that we were just looking at, day 10 A and B, string, which is the method that I added before we started, and these. So that's everything. So we're done day 10, 2 stars. And commit. And forward to here and check, reloading this, and we see it's updated. So everything's good. So thanks very much.
Yes.
We're going to try and catch up. Maybe we'll get another one done today. Anyway, thanks for joining us, and we'll see you tomorrow, hopefully.
Bye.